what? And our particular glucose has on each one of these carbons a what? A hydroxyl group. That's the name of that functional group. And if that's the case, what we're creating then, what this particular molecule has, what this particular functional group, when added to him, what it creates is a polar what? Molecule. You see? Glucose becomes that similar type of molecule that water was, which is what now? Polar. Yes. See, polar means you got a magnet. Yeah? Here we go. If we put this magnet, which is glucose, inside water, which is a whole bunch of magnets, what's going to happen? Yes, that negative end is going to what? Bind what? Have that attractive force created with the what? Positive end. Whatever molecules are in there, and those guys are going to do what? Bond together. They're going to come together. They're going to be what? One. That's why when you look at your soda or juice, that's glucose in there. You don't see little particles in there that's separate from the actual solution. They're all what? One. They're all together. Because that means what? Polar molecules are like magnets. They come together. All right? See, that's the situation with what you call a solution. All right? You have that polarity where all of these molecules are coming together like that. Okay? And they become what? One. Not separated, they're what? One. That's our actual what? Body fluids. We have so many different polar things in there. And what? In what? Water, the solvent. Solutes. Dissolve in the what? Solvent, water. Become one with it. That's our body fluids. Right? We have to understand that principle before we move on. Right? All right, that has a lot to do with everything when you're talking about polarity. Because see, there's things that are not polar. Some things are polar, some things are what? Non-polar. Okay. Yeah. Like for instance, our other biological molecule that's not glucose, right? See, he was glucose, right? Which is considered a carbohydrate. Glucose is considered a what? But if we should take off these what? Hydroxyl groups, which made glucose polar, yeah? And then we actually just add what? Hydrogen. Look, there's no bully here. There is no what? Bully. Okay? And typically with this molecule, it's way more than 6 carbons, I tell you that. We got about 16 to 18 of them. Yeah? Got about 16 to 18 of them. Right? Yeah, this guy's called a what? And the 16 to 18 carbons with just binding to hydrogen like that in your body is called a what? Fatty. And that guy, he's interesting because now, do you see these negatives and positives? No, you didn't have a bully in that scenario who was pulling the electrons more for himself. You know, making this unbalanced what? Net charge scenario. Yeah? You didn't have any charges for these atoms in here. If it's no charges, do you have a magnet? No. There's no polarity. We consider this molecule what? Non-polar. Non-polar, however, toward the end of it. Okay, so right here, this portion right here is non-polar. That portion is what? But typically, at the end of our particular fatty acid, we do have this functional group. And what's that functional group called?
Carbon.
Nice. And if it is, we do see our bully, do we not? And therefore, right? What is this molecule then? It's what? Polar or non-polar? Polar. And every time you have that type of molecule added to the larger molecule, it makes that entire molecule what? Go with it. Now he goes with them, creating that. Now that molecule has a function, right? Which is to be able to go where? Into that wonderful solvent we call what? Water, because water's polar. That's why we need to know about that function. We need to know whether this molecule can go into water. That's what we're made of. We want to see if this molecule can be a part of us. Get into our solution, which is called body fluid. That's why it's important to know its function, a molecule's function. And what helps us understand that molecule's function is a group of actual what? Atoms put together, an arrangement of atoms. That arrangement of atoms, its particular property, which is whether it's polar or nonpolar, is going to let us know when he's added to that molecule, if he gives that function to that molecule. That's why we call that arrangement of atoms a what? A functional group. Yeah. Carboxyl is a what? Functional group, just like your hydroxyl group was. And his property for carboxyl group is what? Polar. He's what? Polar. So what function does he give a molecule when he's added to that molecule? He gives it the function of what? Polarity. To be able to go where? In water. That's his function there. You see? All right? And so that was the same thing with the hydroxyl group we saw with the what? With the glucose, your sugar. And then now we'll have this actual fat be able to tag along with what? That in there, yeah? And go where? Into what? Well, there, fatty acids, if I pull your blood, I can get some. I can check and see fatty acid level. Okay? All right, so, you know, another very important aspect here from what I've gone through with these biological molecules is that when we look at biological molecules, we have to understand that those molecules are brick walls. Okay? What are brick walls made out of? Bricks. See? You got to put a whole bunch of bricks together to make the brick wall. And that's the same thing with our biological molecules. If you're talking about carbohydrates, it's a brick wall. That rice you eat, that's carbs. Any other carbs you got? What else do you eat? Huh? What is it? Pasta, noodles, rice, right? Corn, bread. Those are starches. If they're starch, if it's a starch, what does that mean? That means it's a brick wall made of what? Bricks. Okay? All your rice is, all your bread is a whole bunch of glucose molecules, which are bricks, being what? Put together. You put a whole bunch of what? Glucose molecules together, then you get a brick wall, which is called starch. Okay? That's important to understand that, because now that, you know, we understand that you have to have a monomer. What's that actual brick we call? That's a molecule when it's put together makes that brick wall. That brick is called a monomer. Yes? Mm-hmm. But when you put a whole bunch of those together, you get a brick wall, and now that's many monomers, right? So the brick wall is called what? Polymers. That's it. Okay. Right, and so basically, yes, glucose was the monomer for the brick wall called starch. Well, it's not going to be called starch once it gets in your body. If glucose molecules get put together in your body, it's going to be called what? Who?
Sugar.
It is a sugar.
Glycogen.
Glycogen is in our, it's the place that's stored. Why do we store it? We store it because your body knows that you're going to mess up and not eat in time for when you need the actual monomer. So it stores it in liver. You know, as what? Glycogen. Right?
Storage first.
We'll come back to that.
The other one was starch.
But this guy, he actually gets stored too. You know, this other molecule called glycerol that 3 of these long 16, 18 carbons attached to, and it's called glycerol. And so what we do is we just do what? You have that large now what? You have a monomer, a whole bunch of monomers, fatty acids, coming together, those bricks come together to make a polymer, which is called a triglyceride. Yeah? A triglyceride is just the what? A polymer, okay, of monomers, which are fatty acids. I want to make sure you understand this, though, that what? this portion, the fatty acid part of these polymers, which are now what we call lipids. A lipid, yes, is that fat. A lipid, but its bricks of a lipid are what? Fatty acids. There's this other polymer that's not a triglyceride. Triglycerides, by the way, are stored too for energy. You know where they're stored? The liver. But the biggest place is where? Right underneath your skin. Okay. All right. That's why those people have those big bellies. Okay. There's a lot of triglycerides in there. All right. But yes, your body will get to that as well if you haven't eaten. All right? In fact, it's a better source of energy than glucose. By the way, that's what it is. Glucose is a source of what? Energy. Okay. So that way you can get ATPs. Okay. What's the ATP stand for? Adenosine triphosphate. Very good. Okay. So yes, what we're going to focus on here is that what? Non-polar aspect, and understand that if it's non-polar, does it like water? No. If it's non-polar, does it like water? No. It actually wants to go away from it. It's scared of it, right? So it's actually the opposite of something that's polar, which likes water, right? We actually call that what? Hydro for water what? Philic. Versus non-polar is hydro what? Yeah. Phobia means fear of. So when we have this portion here, we're going to see something develop that's incredibly special from another polymer of a lipid, which is actually called, right, a phospholipid. If we have a phospholipid, what we're going to have is at the end of some fatty acids, we're going to have this other functional group, which is called the phosphate group. Okay. And we got plenty of our what? Bullies here, don't we? You see those bullies? Yes. So with that what? Charge scenario, when we have that charge, when we have a charge for an atom within an arrangement of atoms, then we create a what type of molecule? Polar. And if it's polar, it's hydro what? That means it can go where? Right into the what? Water. Yes, phosphate, a functional group, has given that function of that molecule to be able to go into what? He's going to pull them with it. He's going to pull this actual what? Part that fears water with it. Now if I actually just put that molecule in water, and I'll denote what? This portion right here as the phosphate portion. That's the phosphate end. We call it the phosphate head, right? And if I put him with the what? Non-polar portion, the fatty acid tails. See, that phosphate head with those fatty acid tails, when they're put in water, they form an interesting situation here. Let's just say I did this, right? I just dispersed these in water, right? Then what is our phosphate head going to do? Our phosphate head is going to do what?
It's going to be hydrophilic.
He's fine. Why? Because if he's in water, he's hydro what?
Philic.
So he's fine. In fact, what he'll do though is try to go together with things that are just like him. Polar things, right? So this head right here is going to go to him, right? Yeah. So they start to arrange themselves in that manner. Yeah. And then, now, these guys, they're fine, right? They're fine. Who's not fine in this scenario? See? That part doesn't like water, so you still have water all around here, right? There's water all the way around here. So these guys have to do something now, right?